Hello, Algebra 1 students. This video is going to help you with homework number 3, patterns, linear and nonlinear functions. So I'm going to go to the board and we're going to work on a couple of problems. Let me expand it out so it's a little bit bigger. There we go. So in number 1, I just want to read carefully to see what quantities are going to be compared in the table. So we're looking at our pictures and we can definitely see the pattern that one triangle gets added on each time, but we're not really comparing the number of toothpicks or anything like that. We're looking at the number of triangles and then we're looking at the perimeter. So you can see with one triangle our perimeter is 3. With 2 triangles our perimeter is 4. You're not really counting anything on the inside. With 3 triangles, we've got 1, 2, 3, 4, 5. So we have a 5 in there, and you're going to count the same way around. 1, 2, 3, 4, 5, 6. So we can kind of notice the pattern in words as you add one triangle, the perimeter increases by 1. And then over here, if I'm going to draw the graph, I can number, let's see if I can write on this thing. No, I can't. Darn it. Okay, I just had to get that fixed. So we want to fill in the table. So probably as we have 5 triangles, we're going to keep following the same pattern. As we have 6 triangles, we go up 1. When I get to 12 triangles, I notice now the pattern between my triangles and my perimeter. It seems to always be 2 more, so that would probably be 10 triangles would give me 12 perimeter. And so when we get to n triangles, what do I do to this to get here? It seems like we just added 2 every time. 10 plus 2 is 12, and so on. So as I'm going to be doing my graph, I just want to number my scale. And here's 0, 1, 2, 3, 5, 6, 7, 8, 9. So when I had 1 triangle, my perimeter was 3. 2 triangles, perimeter was 4. 3 triangles, the perimeter was 5. 4 and 6, 6 and 7, 5 and 7, 4 and 6, 6 and 8, 7 and 9. So we didn't get all the way up to 10, but what I can see is that I have a nice linear pattern here. Next, let's take a look at problem number 6 and 7. In number 6, you have to create your own table. So I put these together up here because I want to use number 7 and that nice table that they created as an example. So I'm analyzing what 2 quantities are being related in my table. So I have soap, and that's cups, and water, also measured in cups. So, and then they tell me when I have 1 cup of soap, I have 4 cups of water. So I'm looking at my table and I want to add a few more entries into my table. So if I were to add another cup of soap, I would need 4 more cups of water, so that would mean I would have 8 cups of water. And if I had 3 cups of soap, then I would have 12 cups of water. And so to do an equation, I want to think about if I have n cups of soap, what do I do to n to figure out how many cups of water there would be? And so I just multiply it by 4. So my equation would be something along the lines of, let's see, I probably need 2 different variables for soap and water. So let me go ahead and say S is going to stand for soap and W is going to stand for water. So the amount of water is equal to 4 times the amount of soap. And then you would want to graph that equation on your graph. So remember, the independent variable, or in this case it's S, is going to go on your x-axis, and so water is going to be the dependent variable, and that's going to go on your y-axis. So for every 1 cup of soap, so here's 1 cup of soap, we end up with 4 cups of water, and 2 cups of soap is going to get me 8 cups of water. And so that is about as much of the graph that will fit on there. Let's see what else we have. I want to know a rule that represents the function. So it's pretty hard to see what the pattern is when they're listed out in ordered pairs. So I'm going to pick a different problem. I'm going to do number 12. It's a little more advanced. And so for my x, I've got 0, 1, 2, 3, and 4. And then for my y's, with 0, I've got -1. My x's, I've got 0. For my y's, I've got 7. Now here for 3, I've got 26 and 63. So I'm trying to search for a pattern here. So what can I do to x to get y? So let me see here. All right, so I see the pattern, and you may not see the pattern, but I can tell you one thing. Here I'm going up 1, and here I'm going up 7. Here I'm going up by 19. And here I'm going up by a lot. Let me do the subtraction in my head. 63 minus 26 is going to be, oh gosh, 63 minus 26. That's going up by 37. So we're not going up by an even amount. So that tells me that there's some sort of an exponent going on in my problem. So I have got to take x to some power, and then maybe do something with it, add or subtract something to get what y is. So your job is going to be to look at the pattern and to notice if there's some power of x that you could try, and then maybe see if you could add or subtract something to get your answer. And the last, and I'm going to leave it at that and see if you can figure out the pattern. And I just want to take a look at number 15. It looks like there is a mistake in the wording of this problem. It says, a student says the function shown by the table below can be represented by the rule. And then the rule is not given. So we just want to look at this graph and just say, this table, and say, what is the rule? So I notice that it's going up by 2 every time. And over here, it's going up by 1 each time. So whenever that's the case, I know that I am probably going to be multiplying by 2. So let's take a look at What happens when I multiply 0 times 2? I get 0. So negative 1 is close to 0, it's 1 less. When I multiply 1 times 2, I get 2, and 1 is 1 less. So I multiply 4 by 2, and I get 8, and 7 is 1 less. So I can see that the rule of this graph is take x and double it, but then you have to take away 1 each time. Thanks for watching, and good luck on the rest of the homework.